Welcome to Physics World Online College, where we simplify the concept of physics to you so you can pass your exams in flying colors. In our class for today, bid for SS3, ST3 students, we will be considering conversion of a galvanometer or milliammeter into an ammeter. First of all, we need to know what ammeter is and galvanometer is, and then we will show how to achieve that conversion of a galvanometer into an ammeter. Please remember to subscribe if you have not done so. Share this class video with your friends in other schools so that they will be aware, and then click the notification bell for constant reminder anytime there is a new class video. Let's continue. An ammeter is an instrument used in measuring current. A galvanometer or a milliammeter is used for detecting or measuring small amounts of current. The ammeter is a low resistance device. In fact, an idealized ammeter has zero resistance. Then, the galvanometer or milliammeter can be converted into an ammeter by connecting a low resistance device called shunt. By connecting a low resistance shunt in parallel to the galvanometer. Let's take those points down. I said an ammeter is an instrument for measuring current. While a galvanometer or milliammeter is an instrument used in measuring and detecting. Let's take detecting first. Used in detecting and measuring very small current, very small amount of current. That is why we call it a milliammeter. Milli is times 10 raised to the power minus 3. Now, the ammeter, like I said, is a low resistance device. Ammeter is a low resistance device. In fact, an idealized ammeter, an ideal ammeter has a zero resistance. That's a question on its own. An idealized ammeter has zero resistance. The ammeter is always connected in series to the circuit. Why? So that it can measure the current directly that enters or leaves that circuit. Now, I said to convert a galvanometer into an ammeter, a shunt of low resistance is connected in parallel to the galvanometer. Now, why do you have to connect a shunt in parallel to the what? Galvanometer. That is because the shunt is meant to protect the galvanometer. The shunt is meant to divert excess current that would have damaged the galvanometer. It will be consumed by the shunt. So the shunt serves as a what? A diverter of excess current. I said the shunt is a diverter of excess current that would have damaged the galvanometer. The shunt has a low resistance. Now, what are we aiming to achieve? The issue is, how do we determine the value of that shunt that we need to convert in parallel to the galvanometer to protect the galvanometer, to make the galvanometer measure a very large amount of current? Otherwise, or in the ordinary, the galvanometer would not have been able. What am I saying? If you have a galvanometer, for example, that can have or measure a current of 50 milliamp, that is the full scale deflection of the current that the galvanometer can take. It means if you pass a current greater than 50 milliamp through that galvanometer, it will destroy it, it will damage it, it will burn it. So yet, we want to pass a large amount of current, for example, 10 amp through a 50 milliamp galvanometer. So for us to achieve that, we need to connect a shunt in parallel to that galvanometer. And I've told you the function of the shunt is to divert the excess current that would have damaged the galvanometer. So the task here is to determine the resistance of that shunt, the low resistance of that shunt that we must connect to the galvanometer so that it can measure larger value of current. That is the task. So how do we achieve that? Let's take, for example. So let me show you how to obtain the relationship, to obtain the resistance of the shunt. Let's take a circuit, for example. Let's say this is the galvanometer. Let the resistance of the galvanometer be ROG. ROG is the internal resistance of the galvanometer, or the resistance of the coil of the galvanometer. Let it be ROG. Then let the current that the galvanometer will take be IG. This IG is also the full scale deflection of current, FSD. So when we are given the full scale value as 50 milliamp, that is also the what? Current of the galvanometer. Then we have the maximum current we want to pass through this galvanometer. Let's call that current I. Now, for us to be able to use the milliammeter or galvanometer to measure I, then we will have to put a resistor in parallel. That resistor connected in parallel to the galvanometer is what we are calling shunt. The resistance of this shunt, let's call it ROX. Now, the current, excess current that would have damaged this galvanometer will be diverted by this shunt. So let's call it IX, which is representing the excess current. Excess current that should have diverted, that should have destroyed the galvanometer. So here we have a node here. We also have a node here. So what does that mean? It means that this maximum current, when it gets to this node, will split into two. Part of it will go through the galvanometer, part of it will now go through the what? Shunt. So remember, our objective is to determine the value of this resistance. So what will I do? At this point, at this node, at this junction, the current that enters that node is equal to the sum of the current that leaves that node, Ix plus Ig. This is according to Kirchhoff's current law. What does it say? The current that enters a node, the sum of the current that enters a node is equal to the sum of the current that leaves the what? The node. So I enters this node, while Ix and Ig leaves the node. So we add. So which means if I'm looking for Ix, I can make Ix to be equals to I minus what? Ig. So anywhere I have Ix later, I can substitute I minus what? Ig. Now, using the connection between the galvanometer and the shunt is a parallel connection. What does that mean? It means that the voltage drop across the galvanometer is equal to the voltage drop across the what? Shunt. So let's say, let the voltage drop across the galvanometer be Vg, and I will call it Ig ROG according to Ohm's law. The voltage drop across the shunt, let it be Vx, and according to Ohm's law also, it will be what? Ix ROX. And I've said, since the system or the circuit is connected in parallel, it means that the voltage drop across the galvanometer is equal to the voltage drop across the shunt. So I say, since the circuit is connected in parallel, then the voltage drop across the shunt is equals to the voltage drop across the what? Galvanometer. Voltage is the same for parallel connection, while the current is different. That is what we have. Different or the same. So in place of Vx, I'll put Ix ROX. In place of Vg, I will put Ig ROG. If I make ROS a subject, I have ROS is equals to Ig ROG all over Ix. And I can write it preferably this way, that ROX is equal to Ig over ROG. In place of Ix, now I will put this relationship I minus what? Ig. You have to take note of this formula. So once we want to convert a galvanometer to an ammeter, we can use this relationship to achieve that conversion. Simply substitute the values. Now, if I don't want to use this, we can also use this representation, or RS is equal to IG rho G is actually VG all over what? I minus IG. You can use this relationship as well. You are correct. Good. Now we can solve this particular example. So we can solve example 1. So let's take solution to example 1. Solution to example 1. The question says a galvanometer of resistance 2 ohm, that represents the resistance of the what? Of the galvanometer. Solution to example 1. To example. Now, so we are given the resistance of the galvanometer rho G as 2 ohm. Gives a full-scale deflection when a current of 50 milliamp. That full-scale deflection, I said, is the same thing as the current of the what? Of the galvanometer. So rho G is 2 ohm. Ig, which is the same thing as IFXD, is what? 50 milliamp. You have to remove that milli sign by multiplying with 10 raised to power minus what? 3. That takes it to what? Ampere. So 10 raised to power minus 3 times 50 gives you 0.05 amp. Good. So we are looking for the value of resistance. You say, how will you convert it to an ammeter capable of measuring 10 ampere? That 10 amp is now the maximum current I. This maximum current. So I is what? 10 ampere. So for us to do that, we apply this formula as we have it. So using the formula that rho x is equals to Ig rho G over I minus Ig. We substitute our values. Ig is 0.05. Rho G is 2 divided by I max is 10 minus Ig is 0.05. This gives me 0.1 divided by 9.95. So that will give us that ROS is equal to 0.01 ohm. You see that the value of the resistance is very small. 0.01 is very small, low resistance. Why is it so? The low resistance means it can absorb large current. And these resistors will be connected in parallel. You have to take note, because in most of the question they ask, how will you connect it? So you connect the resistor of low resistance in parallel to the what? Galvanometer. This resistor of low resistance connected in parallel to the galvanometer is called shunt. This resistor of low resistance connected in parallel to the galvanometer is called shunt. So like I said, what the shunt is doing is to divert the excess current that would have caused a damage. So what are the things to take note of? here. Once an equation has been established, you can be asked to calculate for anything, as this is as a classwork or assignment are showing. Now, I want you to take note of two things about this conversion of galvanometer to an ammeter. One, it is about current protection of expensive device. What does that mean? If this galvanometer now I replace it with an expensive machine that costs millions to buy, you must have to protect it against overcurrent in the industry, because once excess current enters into it and damage it, it will cost the company a lot to be able to repair or replace it. And once you are not able to repair that machine on time, it means the company will be losing money, and it can put the engineer in that company in problem. So what do you do when you have an expensive machine, a costly machine in your company? You must protect it against what? Overcurrent. So in order to protect that expensive device, look for a low resistor or a low resistor device and connect in parallel to that machine, which means when there is excess current, there is current surge, maybe due to fluctuation of NEPA light, instead of the excess current to damage the expensive machine, it will rather damage the what? The shunt, that low price device you have connected in parallel to the what? To that machine. That is one of the advantages. Two is that we are using this shunt to increase the current range, the current rating of what? This galvanometer. What are we saying? The current that this galvanometer can take, based on this question, is 50 milliamp, which means the initial range is 0 to 50 milliamp. Now, by connecting a resistor of 0.01 ohm in parallel to this galvanometer, we can now use it, we can now adapt it to measure a current of 0 to what? 10 amp. So we have increased the range, the current range. We have increased the rating of this what? Galvanometer or instrument. So that is why you have a question here that this with the rating. So you say a galvanometer of 0 to what? 10 milliamp. That is the original. This means that the value of the galvanometer, the full scale value, is what? 10 milliamp. Now it's increased to what? 0 to 10 ampere. So this 10 ampere is now the maximum what? Current. So they say, how will you what? Achieve that range adjustment? Using what value of what? Shunt. What value of resistance will you what? Use? I hope you understand. So two important purpose that this conversion of galvanometer to ammeter fulfilled. You want to learn more about it. Now, if you have a formula, you can be asked to look for anything. So there are questions mostly that ask for the value of the resistance and how it will be connected. It is low and connected in parallel. There are values where they give you this value of the resistor of the shunt, as is given in this example, and then they ask you for the rating of the galvanometer. Is possible. Or they give you the value of the shunt, give you the rating of the galvanometer, ask you the value of the maximum current I that you can now adapt it to read. So all you have to do is to make I the subject of formula in that question. Please, I leave you with this classwork and assignment 1, 2, and 3. Solve it and send your answer to me. I will reply you accordingly. Thanks for your time. Bye.